James Webb Telescope, terrifying discovery at the edge of the universe. We are teetering at the edge of a dramatic breakthrough in astronomy, and we have the James Webb Space Telescope, known as JWST, to thank for the incredible advancement we expect to see. The world's most advanced, most extensive, and most expensive telescope has been nothing short of fantastic since it took to space, aiming for its destiny. In today's video, let's take a look at the terrifying discovery that awaits the JWST right at the end of the world as we know it. The world in question encompasses the entire known universe. It makes you wonder just what kinds of sights await us at the edge of our universe. More universes? We'll see about that in an instant. Watch this video to the end to find out more about what the fantastic telescope has found that could change how we perceive the universe. The JWST was designed for a great mission by design, and it was built just enough to do this job incredibly well. There are high hopes for its discoveries, given the grave importance it holds for the future of astronomy. It wasn't too long ago when JWST was launched. It was a pretty expensive one, as it had cost NASA over $10 billion to finalize its build, and it was indeed a day of joy when JWST was launched on December 25, 2021. It took about 10 years to get it ready, and then when it was ready, its departure was met with quite the fanfare. The thousands of engineers, scientists, managers, and support staff that contributed to its mission were exceedingly thrilled by its prospects. The telescope's goal was to settle on a peculiar position called the Lagrange Point 2. The location is said to be the spot lodged behind Earth, but it would be in the view of the Sun. It would then take powerful shots of distant celestial bodies with its insane infrared vision that could pierce through interstellar particles or clouds of dust. JWST is undeniably the perfect replacement for the aged Hubble Space Telescope, but a more relevant term would be successor. Why? Because it might lack the durability of the Hubble telescope, even though it's capable of observing more powerful projections and getting some high-quality shots compared to the Hubble. The Hubble telescope has been in space for no less than 30 years, and the purported duration suggested for the JWST to last in space is no more than 10 years. But the fact is that even in those 10 years, it'll do a marvelous job of exposing us to the myriads of wonders that lie in the universe at large. Mind you, the Hubble telescope is not out of commission yet, and it's still efficient enough to do more excellent work. We'd expect both telescopes to hasten the advancement of our scientific knowledge concerning space. We hope to see more amazing views of the universe through the eyes of the scientific results they capture. The Hubble telescope has shown us some incredible features of the world that we now know thanks to its small-size 2.4-meter diameter mirror. We rank it as small because ground-based telescopes tend to be larger. The major demerit to its small size is that it can barely observe faint objects due to the low sensitivity of the mirror. Even with the infrared light ability, when it comes to observing stars and universes that have been suggested to be much older than ours probably, it's incapable of studying the wavelengths of light that they produce. But guess what? The JWST is much more efficient at observing these ancient stars. The two telescopes are designed to study the same materials assumed to have remained of the Big Bang. Of the two, JWST has the highest potential of doing these well. The materials now appear as nothing more than a group of stars known as population 3 stars. That's the category under which stars formed from the primordial material deemed to have been left over from the Big Bang, which birthed our universe. For the time being, this is nothing short of a theory though, as these materials are yet to be observed. But they could hold the key to understanding the building blocks of the universe and how the first galaxies were formed. We understand that this is one of the most critical scientific questions posed, and ultimately one of the primary science goals set for JWST. It has been thought out that the necessary elements that sustain life were first produced in the early stars. How they produced eludes us though, and people in scientific circles are still embattling that gap in our knowledge. The need for observing these faint objects led to the advancement of the JWST. The fact that JWST is the largest telescope resulted from deductions that a giant telescope would be needed to detect faint objects in the distant universe. Its wavelength coverage would be excellent, and it should also be able to cool itself off, thus reducing background light that would interfere with the vision of the telescope. We hope you're enjoying our video. What are your predictions about the chances of JWST to better the results of the Hubble telescope? Subscribe to our channel and click on the notification bell to get notified about our future videos. As much as the discovery of the origin of the universe is the prime objective of the JWST, it's tasked with providing necessary data to help researchers gain more accurate information to back existing research. For instance, the infrared vision of the JWST comes with the extra advantage to be able to see through clouds of dust that often surround relatively young stars. The dust appears as an opaque covering that hinders visible light. We'll get to see more of the stellar nurseries that nurture the stars that grace the universe, and we might even get to see how the numerous planetary systems are birthed. The long-standing theory suggesting that stars and planetary systems are born out of the collapse of gases and mixed in with dust clouds may finally be put to rest. New Earth? Maybe. The theory of the universe has opened up our ideas to the fact of the existence of other universes, and then the potential that there could be other planets out there just like our Earth. And there's the likelihood that these exoplanets could be habitable. True to life, we have observed thousands of other planets that fit this bill orbiting lazily around their stars. Further observations are expected with the JWST to study the atmosphere of these planets. Its wavelength coverage is fine-tuned to study these bodies that may very well be billions of light years away from us. We aim to see just what else lies within our grasp in the universe. JWST is pointed positionally to identify faint objects that could appear to be the size of a bumblebee. It's expected to help us see the planets that have probably been in existence for over 13 billion years since the birth of the universe. The gold-coated 6.4-meter diameter of JWST can reflect the infrared light produced by these early stars, giving us a clear image of what they are, and maybe tell us a few of their stories. The JWST would be actively observing solid infrared rays requiring cooling. That's where its great 5-layer sun shield comes into play. The shield is arguably the size of a tennis court, and it was folded on launch, but when it reached space, it expanded and has been shielding the telescope ever since. The shielded side of the telescope will be cooled to a temperature of about minus 370 degrees. It's the perfect sun protection factor. It would have been nice if the telescope was mounted on a human-crewed spacecraft before shuffling off to its next observation point. Or maybe astronauts would be sent to make service calls to the telescope to fix some of its effects of the launch and settling, such as initially blurry vision and performing maintenance services. We understand that was done with the Hubble, but that was located a mere 340 miles away from the Earth. But JWST is more than 1 million miles away. That distance is way more than any human-crewed spacecraft has ever ventured before, thus it's out of our reach. Hence, the expedition of JWST is one-way traffic. We expect that sometime in the future, we might get to see a robot craft sent to the JWST to refuel it, and thus ensure that it lasts longer in space. The good news is that it could last more than 20 years instead of the primary concerns observed. Are you curious about what the first photos of the James Webb Space Telescope would look like? So that's all the time we had today, folks. Don't forget to subscribe to our channel and hit the bell icon to remain updated about all our future videos. See you all next time.